In ShiftExample7LWU, we have a unsigned int a set to 1, 1, unsigned int b set to hex 2, 2, and we take an argument on the command line, put it into the signed integer c, and we're going to do b shifted left by c, and then minus equal that value into a. So here is the code that generates, and there's no new assembly instructions, and these are not the instructions you're looking for. At least they're not the instructions I'm looking for. Because at this point in the class, I am trying to hammer out the last assembly instructions that we're missing and finish off our checklist. So what I'm looking for right now is LWU, and I was not able to find LWU until I played this little game with shifts. So specifically, I had to play the game and use Clang because GCC would never create this LWU for me, but Clang would. So this code will generate a new assembly instruction LWU, and we're going to see that now. That is load word unsigned. So we've already actually seen load word a long time ago. Remember, a word is a 32-bit value, but load word unsigned is going to say don't sign extend it, just 0 extend it. So load word unsigned, we have a source address. So this is a load, it's coming from memory. Source address plus sign extended immediate 12, and take that as a memory address. And then here, because it's unsigned, we're going to 0 extend the 32-bit value into the 64-bit register. Recall that LW was one of those W suffix things that is a RV64I assembly instruction. So I could tell you the repeated things that I always tell you, like this one reads from right to left, so memory over here into register, or the fact that the parentheses means that you're reading from memory, but I won't do that. I won't bore you with that copy and paste repeat from earlier in the class. But I will tell you it is now time for you to step through the assembly and make sure you understand what's going on.